Our first speaker in this room is Majid. And Majid is super experienced developer from Oslo, Norway. And actually, he is the host and organizer of NG Vikings, the big conference about, not only about Angular, yeah?
Particularly Angular, yes.
Okay. So you don't have, like, you have zero React there?
No.
Finally. And Majid will speak about like complicated things in Flutter and Dart. So please welcome Majid.
Thank you. Hello, everyone, and thank you for attending today to my talk. Yes, I'm actually talking about a little bit complex stuff. Especially, I remember when I started building our first Flutter app, like almost a year ago, or more, before that Dart. There was no example of how we can architect our application, and our application was quite big. So we spent quite some time and educated ourselves, especially myself, and then learned best practices, patterns, and different stuff. And we knew some stuff, and then we applied it to our application at the end of the day, and then we found out that, okay, it works, and it's scalable and sustainable. So now I'm going to share these knowledge and experience with you. And whatever I say today is actually my personal experiences and knowledge. So however is your application, whether it's big, small, or whatever it is, you can take an advantages of these slides and these knowledge today. You don't need to apply all of them. You can just grab some of them, or you can apply all of them, or add some additional stuff to it. So I'm going to talk about domain-driven design, but just a strategic part, and see how we can improve our Flutter architecture. Well, before I start, how many of you actually started an application, or you want to start an application, and in your imagination, you are going to create an awesome architecture of the application, like everyone loves it. If they see, they immediately understand what it is. All of us, right? Who wants to write a messy code, or who wants to write a messy application? No one. I mean, the imagination is like this. It's awesome. Like, I just go to the data center. It's amazing. I see every little thing here. How everything is connected. Nothing is inside it. I literally understand everything. But then after a few, maybe months, I'll get here. Then I don't know what it is. Which wire goes to where, and where is the service? Where is my data layer? But how can we fix this? So there are multiple approaches. The main important thing is that, well, we can share our experience. Okay? We can go and learn best practices. There are actually multiple best practices out there for building a software. Or when you actually combine multiple best practices and kind of formalize them, then we will end up having patterns. We have multiple design patterns or patterns right there for building a software right. And then once someone comes and just combine all of these patterns and best practices and then somehow add some philosophy to it, then we will end up having methodology. And actually, domain-driven design is one of those methodologies. So all of the contents regarding strategic and tactical domain-driven design and slides are inspired by this book, which is around for maybe 20 years-ish, something. It's not a new concept. And also these two books. So we are here to, according to this book, tackle all complexity in the software. By the way, the books are so thick. Each of them, I think they are around 700 pages or something. What we are going to learn today is, I'll walk you through the domain-driven design shortly and see what it is, what it wants to do. And then we talk about the strategic part of it. And then we try to be inspired by that and apply it to our Flutter architecture in application. It could even be applied to any other software application. And then I'll show you a short demo, like how it could be possible code-wise. Let me introduce myself, even though Zhenya has done that. But my name is Majid. I'm flying from Oslo to here to see an awesome Dart community here. I'm so impressed, actually, like so many Dart and Flutter guys and girls in this room. I'm very impressed. Well done. I'm a passionate developer just like you. I'm not super like what he said, but I'm a passionate developer just like you. And in my spare time, I do many things for the community, running meetups, conferences. I wrote a book, and I'm also co-founder of Softiware, my company. So let's get started. Domain-driven design. When we start to develop, developing a software, probably the primary things that it comes to our mind, the primary focus is to think about the technology first, right? Actually, in domain-driven design, it says you don't have to think about technology first. You have to think about your business first. The software is here to help your business to grow or to solve your business problem. And that is actually the domain. The domain is your business and a problem that you want to solve. Like, let's say I'm working in an e-commerce platform, for instance, and my domain is e-commerce, right? And software helps me to solve the problems around this domain. But don't you think that this is so abstract? It is so abstract, right? So there are multiple tools that helps us to kind of tackle these problems. In domain-driven design, we have two tools. We have strategic design tools, and we have tactical design tools, or technical tools. So in the strategic part, we are all thinking about planning, splitting up our application into smaller pieces. We plan beforehand, before we start developing our application. And the tactical part is all about design patterns, applying these patterns, and layer architecture, and all of these things. Today, my focus is the strategic part. We will just go through the strategic part and be inspired by that and see what it is exactly. But why I choose actually a strategic part? Because, well, if you don't plan properly, you will end up having like a mess at the end. And everyone wants to come and refactor it, and at the end of the day, there is a big legacy that no one wants to touch it. So let's plan properly from the beginning. So this picture exactly shows what I mean. So we're going to have a nice city here, which is modularized, and each single, let's call it microservices or whatever you want to call it, They just talk to each other through an API, and they all know what they are doing, right? So clean, so clear. But if you don't plan, then you will end up having this. You don't know where you live. So strategic is all about decomposing. Decomposing your domain, your software, into smaller pieces, to smaller pieces that everyone understands. And that's what we call it actually subdomains. So you start thinking about your subdomains in your application. Let's think about the context. So it is very important in strategic domain-driven design to think about the context always. So what does that mean? What do you mean about context? The context means that, like let's say, as an example, my business context is e-commerce. Then in that e-commerce, each subdomain could be different things. Could be sales subdomains, could be product catalogs, could be support, could be accounting, could be order, and multiple other things. And in each context, I have different approaches to solve that problems. So each subdomain has entities. They could have multiple entities. But the entities in each subdomain has a slightly different meaning in each subdomain. So in sales, I have a customer which sales subdomain is interested in their interest because they want to sell to them, right? But in order subdomain, I have the same customer, same ID, but they are interested on availability of the customer. Right. And each subdomain are bounded, like they are isolated already, so they don't link to each other. And that is what we call in domain-driven design bounded context. So you define your subdomain and you isolate them through a boundary. And then inside each of these boundaries and subdomains, there is a unique language for everyone on that subdomain. That is what we call ubiquitous language. So everyone in each subdomain will talk the same language, and everyone will understand what we are talking about. From domain expert, business guys, from developers, analysts, or whoever is working in this subdomain or this module, let's say, they understand. And we even reflect that language to our code. So domain-driven design, it's not here. It suggests actually not to even unify this language. Like, let's say, let's have a ubiquitous language between all of our subdomains. Everyone speaks one language. But no, that's not it's supposed to be. So, but what if this subdomain wants to communicate to each other? So you don't want to build just a subdomain that is super isolated and nobody can talk to it, right? So perhaps, like in this example, like accounting, support, and order subdomains, they want to get some information from sales. That is what we call it context map. But is it a good idea, like everyone like this, get an access to the subdomain? Okay, we decomposed our application, sounds awesome, but then now everyone can get everything from everyone. What now? That at the end of the day, we will end up having the same mess, right? But how can we solve this? There are multiple approaches. I'm talking about two particular ones. The first one is shared kernel. The idea behind it is that each subdomain, if they want to share something with others, they put everything into the shared kernel. And then everyone can handle that and can get the data from that. But okay, everyone, like everyone is responsible? Who can tell me if everyone is responsible, what will happen at the end of the day? No one is responsible. Right? But is there a better approach? Yes, maybe. What if I create a thin layer in my subdomain that is just exposing what I want to be exposed to other domains, and every single subdomain just get the data from that tiny layer? So they don't access to anything else inside the domain, just that layer. That is what it calls in domain-driven design open host service. Or, okay, open host service, if I want to translate to our language as a developer, it's API. That is API. So you provide API to your subdomain, so other subdomain can get access to whatever you want to expose to outside. So I didn't actually summarize 1,400 pages in the 2 books into 5 slides. There is a lot more. But I shared what I think it's very important for us, or at least for me, to architect my application. So we talked about the ubiquitous language, we talked about bounded context, we talked about context map, and how these subdomains can communicate with each other. But okay, that is all theory, that is all nice, but how can I apply it into my Flutter architecture? Okay, based on what I learned, and we learned right now from this theory, and based on our experiences in writing application, we ended up having an architecture like this. So we talked about e-commerce app, right? I just focus on 2 or 3 subdomains at the moment. But of course, we can go through all of the subdomains. And by the way, finding subdomains, planning for that is one of the most difficult jobs that probably you need to do. It's not as easy as I present it. So we will have sales, catalogs, and command. So in catalog, probably it's my core domain, right? Every other subdomain, they want to get the data from this catalog. Like everyone is responsible, is dependent on this one, probably. So that's what I can call it, the core domain. So, but I have the catalog, and I have the sales, and maybe a common. The common wants to share different things to many of the subdomains, okay. So the first layer in each subdomain, which I suggest is presentation layer. Probably many of the ideas right now are familiar to you. So the presentation layer, in my perspective, is containing smart UIs or features and widgets. And the smart UIs or features, they are the part of application that we can say in Flutter they are pages or screens. Or one part of these smarter features are logic holders. Or you can think of it as state management, for instance. You can use whatever you want in this sense. You can use block if you like. You can use a change notifier. You can do whatever you want here. So, and the next, so one subdomain could have multiple features or multiple smart layer. So smart layer is the one that you provide, for instance, in sense of block, you provide your block through the page, and everyone, all the widgets will inherit from it. So the next layer is application layer, which I suggest. Application layer, in my perspective, is use case-specific facades, the facades patterns. What is a facade? Facade is here to simplify getting access to multiple other services, for instance. So you create a layer that is simplifying everything for your presentation layer. Okay. And then the third layer is domain, the actual domain layer. And what is it? This layer is an isolated layer that only knows about this subdomain. So it only knows what kind of entity this subdomain needs, what kind of interfaces or logic we need to write for this subdomain. So this layer doesn't know anything about application and other layers. It's all encapsulated related to this particular subdomain. As an example, let's say we have a catalog right now, and the catalog has product entity. And the entity here has multiple properties. And then we have interfaces, because we don't know about anything else, but we know, for instance, in interfaces, it's an abstract class. We know that we want get or fetch products. We know that we want get product with by ID, for instance. So we define them in an abstract class. And then we also know that, for instance, we want some kind of logic in our domain which is unique to this domain. What does that mean? That means I have a product type, and there is no API, nothing in the data layer. So I want, whenever I say this product is, for instance, simple or variable or external product as a type, gives me the manufacturer. And that is a logic which I write in my domain. So I pass in my product type, and I receive manufacturer. So put it in my domain, because that is specifically for this domain. And then the last layer here, infrastructure, as I suggest. So in the infrastructure layer for each subdomain, we will have, the first one, we will have data sources. What are the data sources? Data sources are responsible for fetching the data from remote or local data source. Let's say I have a REST API and I need to fetch all the products. So this is my remote data source, which HTTP is there, and then I get all the data. And once I get it, I cache it somewhere. Shared preferences, right? I cache it in my device. And then I cached it, okay. Then I have another data source, local one. Now I have a cached version of my product. So if I need it, I can get access to it. So these data sources, they just give me raw data. And then you send it through models. So models are actually extending entities. So see, so infrastructure layer knows about domain. So they extend entities. But what they do on top of the entities is that they transform your raw data to whatever format you want, from JSON to JSON, as an example. Maybe you have an XML, or maybe you have a different type. So you are transforming your data here. So a domain above, a layer above, they don't care. They just receive the entities. So you transfer everything here. So it really doesn't matter at the end of the day if the API, your server APIs has changed. You just change the tiny part down, and then all the rest are fine. And then you have repositories. And what are repositories then? Well, repositories are responsible for providing a proper data source to a layer above. What does that mean? An example is you have now remote and local. Let's say you want to actually get the data from local when there is no connectivity, when there is no internet. Where should you put your logic here? You should add it to your repository. So in the repository, which is extending the interfaces from domain. So the repository already knows which kind of method they need to be created in them. So because you are extending the interfaces from domain. So the data layer is actually a layer who is serving to domain. So I will, in my repository, I will have these methods, and then I will add my logic. If there is no internet connectivity, go to the local data layer. But if there is a connectivity, go to another remote data layer. Or maybe you want to handle your errors or error handling. Fantastic. Okay? You can actually do that in here. So if you catch any error, then you can return your proper error handling way of viewing what you want to do here. So, but how does that work? My rule here is that from top to bottom, each layer access to a layer down. So that means from presentation layer, you never ever get access to infrastructure directly. You go to application layer. And the application layer is the layer that is simplifying getting access to both domain and infrastructure. And then serve it to the layer above. But okay, what if sales wants to get some data from catalog? Okay, we talked about it. If it's required, create a small, tiny, thin layer to provide the APIs, expose it to outside. What is the benefit? Why not getting access to the data directly from application or from infrastructure, from like catalog? Like from here, I directly go to here. Why not? The reason is that if you provide an API, the main reason is that you can easily refactor or change all the other things inside this subdomain. But your API, your public API, it's always the same. So if you refactor your catalog for some reason and you want to change the whole stuff here, okay, you don't need to go and change it here. Because at the end of the day, you get the data from a public API, and that is unchanged. And the API is getting the information from inside the subdomain. So it makes it easier to even test. Each of these subdomains are isolated. They have a boundary, so you can even test them independent. Or if you go and architect this, so at the end of the day, you can even make them as a package and then reuse your subdomain in multiple applications. And why not? What if in your company, you want to create another application which actually needs catalog, the same catalog that you are using in the current application. But then, okay, then you can have a package. You can host it locally and install it in your application and reuse it. So the layer architecture here also helps me to change each layer without notifying a layer above. In many cases, refactoring is way, way easier. So, okay, theory enough. Let me show you some codes. Let's go through the catalog and see actually how it reflects as a code in a Flutter application. Just in case, I added this here, but you don't need to go through it. We'll go through the code right now. But as a reference, if you later come back to the slides, the code is public under my GitHub, but you can always look at this chart too. But let's have a look. So that is my application. By the way, this is an example application. So I have my library, and then I just created catalog as my subdomain and a common folder. So there are some stuff that I want to add them somewhere, and you can also expose them as a package to your application. Like, well, I need some configs, I need exceptions or failures or success objects or helpers, which usually time to time you want to have it in different files, or utils, or for instance, network, checking the network. And these stuff are common, right? So we can have that here. You can have that here and also expose it via an API and then release it as a package for yourself, like a local package. But let's go through the catalog. So what I actually spoke is already reflected here. So the folders, the structure of the folders are similar to what I presented. So I have an API, presentation, application, and domain. Is it visible down there? Okay. I can make it bigger if it's not good enough. Okay, good. So let's go through presentation layer. My presentation layer consists of 2 features, 2 screens, and 1 widget folder, which has the common widget for this particular UIs. Like as an example, I need to create my category name that's a design that is unified everywhere in my applications. So I want to create here as a stateless widget. It just gets the product name and then render it in some design. And then I'm going to go through the list and details. So each of these features has their own block. I'm a big fan of block. I think it's one of the best state management for Flutter. So I use block in this case. And my block has, of course, if you're familiar, it has state, event, and block. And the block is actually getting access to catalog service or catalog facade service. This is the application layer. So I instantiate via dependency injection the application layer into this particular block. And then I do whatever I want to do. Like I want to fetch product and then change the state, product is loaded, and then I have the product. You see that I don't care about anything else here. It's a simple logic for my presentation, my UIs. And then I go through the screen, list of screens. So obviously, I provided my block, and then I built my widgets with block builder. And based on the different state, I will load my product here with category name, which was a widget located in the widgets folder. Same goes for details. And then I can use this screen for my routing system in Flutter. So, but like I said, in the block, we get access to the application layer. We instantiate the block with facade. And what does that mean? So this is my application layer. So I have catalog facade service, and it has access to repository. I mean, it gets instantiated by repository via dependency injection. And I'm also using mixing called catalog logic, because I'm interested in all the logics in my domain. So here, now technically I have this function, get official product manufacturer. Then I can use it in my block. So that is my application layer. So now I have only one repository and one simple mixing logic, but it could be even more. So then I go to my domain layer. I have the entity. This is my entity. So in this particular domain, for instance, I am just interested in ID, name, price, and description. Or maybe more, because this is catalog, then maybe we need all of them. That is just for demonstration. So then, if you don't know, by the way, I'm using equitable. It helps to, for equality, you know, in Dart, we need to override the equality operator. So, but equitable helps to make it even easier and very handy. So, and then I go to my interface. Well, what was my interface? Because I said my domain doesn't know anything about the different layers, but I am telling from my domain what I want to create later, and this is the abstract class product interface. So I say that I want fetch products, which is returning a feature list product, and I need also get product by ID, which is returning a feature product. And the product is entity in this domain. Okay. And then I have my logic, this mix in. So I just create this because I want to kind of organize each of these functions into different files, because I like this way. If you don't like it, don't do it. And that's the logic behind this function. Maybe it's unnecessary for this one because it's very simple, but at the end of the day, organizing these codes helps to understand it better. All right, so, and then I go to my infrastructure layer. I have data sources, 2 data sources. You may have more. I have my models, and I have my repositories. In my model, let's get into it. You see that I'm extending product entity already. The only thing that this model does for me is from JSON and to JSON, I serialize and deserialize my raw data. And in my repository, I have access to different data layer, data sources, and another service for checking connectivity. And as you see here, I'm implementing product interface from domain. So I already know what I want to create here in this repository. And then fetch product, obviously I'm checking if it's connected, and then I return from remote data source, or if it's not, local data source. So for the rest of the methods is the same. The local data source and remote data source are those that they have. In the remote one, we're going to have HTTP, make our calls, and get the raw data, and return via the model. And then in my remote, I get it from where I like. For instance, I like it, like use SQLite or anything else in my application. I just implement the logic over there. And I have also now, for this architecture, you see that I have instantiated different repositories, data sources, and services into my different files, right? And this is happening via the dependency injection. And for the sake of making it easier for me, I'm using getit, a package that helps me to make it easier to inject the different services. So, and here is what I do. If you have a dependency injection tree in your application, you want to do that for this particular architecture, this is how you have to do it. You look at it from top to bottom, to the layer architecture. So the first thing is I have my catalog dependencies here. So the first thing is my presentation layer. What is there that it needs to be injected? Of course, it is my catalog service. My catalog detail block. And the catalog detail blocks, if you remember, it had catalog facade service, which I am injecting already here. And then one step below, I'm registering as a singleton, I'm registering this service here, which already has different, which already has a repository as its dependencies. And then I go a next step, like a layer down to infrastructure. I have my repositories, which they already needs to be injected by data sources or network layer services. And I register my data sources at the end. And at the very bottom, whatever it's common, like network connectivity. So very, very nice dependency injection tree. So, and then I'll just instantiate my service locator in my main application. All right. So what we have learned today, to summarize, first of all, we went through domain-driven design and what is the domain and what is the purpose of having this domain-driven design in our architecture. And we talked about the strategic part of it. We talked about ubiquitous language. We talked about bounded context and context map. We talked about how we can actually communicate between subdomains. And then at the end, we inspired by this isolation, these contexts, these boundaries, and these languages, and created an architecture, a layered architecture. And the layered architecture that I suggested is based on actually two famous layered architecture. One is Clean architecture by Uncle Bob, and another one is Onion architecture. But I actually definitely changed it. So I changed it to how I like it to be, and it worked for my application. You may get whatever you want to apply to your application from the slides. It's fine. You can get access to the slide via this URL, very simple one. And if you have any question, I'll be around. And you can also follow me on Twitter and keep in touch. Thank you for listening.
Thank you, Majid. Right in time. Yeah, it's perfect. So you can ask your question in the application, and you can ask them in Russian. So, and our first question is, why you need a separate models and domain? So, what is the problem with trying to solve?
Of course, that's a good question. You don't have only one entity in a subdomain. You may have multiple entities. For instance, let's say in sales, you have product entity, and then maybe you have something else. You have customer, and then you have sales, and you have different entities. And when I say models, that means each entity needs to have a model to serialize and deserialize, right? That's why you need multiple of them. One subdomain, for instance, the catalog one, may have only one, but in subdomains, maybe you have multiple of them.
Mm-hmm. And the next question, it's not quite a question. It seems too complicated structure. How can we make it simpler, like MVC pattern?
Yeah, it is complex. The reason behind this layer architecture is if you have a very tiny app, maybe have 10 screens, you may not go with this architecture. This architecture is helping enterprise application, like big, giant application with multiple teams that working on the same app. But there is a big but here, not but but. The thing is that, inspired by these layers, you may want to actually grab one layer that you like and apply it to your application. Like I said, for instance, you may just get the presentation layer and infrastructure layer and get rid of the domain and everything else. Because in your application, it's simple and it makes sense. Where you get your data in the presentation, like in block, where did you get your data? Repositories is where you have to get. And that is actually suggested by block itself, with the block pattern. So you have your block, you have your repository, and you have multiple data sources. So, like I said, that is the complete solution for an enterprise application. Like my example, my application, when I'm working every day on it, and it makes sense for us. But for you, when you have a smaller application, you may want to just be inspired by one part of it. And that's it. But this is very important to understand each module, what they do, and each layer, and why we do these layers, and which layer may be suitable for you and may not.
Okay, and we have time for another one question. You've talked in details about ways to improve application architecture. Yeah, but in contrast, what are some of the common mistakes or pitfalls that go against DDD? So maybe some insights from you, what we should avoid when we're trying to solve this problem.
A good question. One of the most important aspects when it comes to strategic part of domain-driven design is finding the domains, subdomains actually. That is the part that usually we make mistakes. We ended up having maybe wrong subdomains. So one of the common probably mistakes is when we don't talk to anyone in the company and just the developers to create these layers. What I suggested here is that when you want to architect your application, before you start architecting and coding, go to your business and domain expert, talk to them, and understand them. Because we as a developer at the end of the day, we create the software to solve their problem. We solve the problem. Even though if you are working in a software company, you still have a domain, and you still need to go and talk to the business and stakeholders and all the everyone who is responsible for each of these to find each of these subdomains. That is probably the common mistake that it happens in domain-driven design. But when it comes to the tactical part, so when it comes to the architecture in the layer part, when I explain, that is actually a tactical part. So in that particular section, there there will be multiple pitfalls and issues, and you may not even like it, like you don't like this layer architecture, maybe you want to go with another architecture, but the purpose of the talk today was to focus on the strategic part. The tactical part, that was a suggestion from me, my experience, and my application, right? And then I suggested, and I think it works perfectly. But I already knew that I have different subdomains, and I created my isolated domains and everything else before I started creating this tactical part, right?
Okay, and that's it. We don't have time for other questions, but you can ask them in speaker zones after the talk.
Thank you very much.